Hello and welcome. Today I'll be discussing the 1.5 rate of chemical change exam style worksheet questions. The first question you were asked was that a student carried out an experiment to investigate the speed of the reaction between a lump of magnesium carbonate of mass 0.32 grams and excess dilute hydrochloric acid at 20 degrees C. Magnesium carbonate reacts with hydrochloric acid to form carbon dioxide gas, and therefore the total volume of the CO2 was recorded every 5 minutes, 40 minutes, using this apparatus. And we can see the results here. The result at 50 minutes is missing. So using the diagram, it asks us to find the volume of CO2 formed after 50 minutes. So we can see that the bottom of the meniscus sits, which is by here, sits at 2 volume units lower than 60. Therefore, from the bottom of the meniscus, the reading we would get for this would be 62 centimeters cubed. The next question asks us to plot the results from the table, including your answer to part A, and then draw a suitable line and label the graph X, bringing back the table including our calculated answer. This is what you would get if you joined the dots. However, we can see this is not ideal because of this. So this would be a lot better because this allows for a nice smooth curve. Then, question C asks us to sketch the graph we would expect if the experiment was repeated using the same mass of magnesium carbonate powder instead of a lump, and we can label that one Y. So what we want is a steeper curve, a curve left of the original and ending at 90 centimeters cubed. There's a lot of choice here, but this is what I've gone with. And again, we should like to see a smooth curve here. The next question asks us to state and explain using particle theory the effect of increasing the concentration of hydrochloric acid. So how we would explain this is that there are more particles, thus a greater chance of collisions, or more frequent collisions, and therefore we get a higher rate of reaction, or a faster reaction, however you would like to word it. Part E of this question is about a student investigating the same reaction using a different apparatus, and a lump of magnesium carbonate was added to hydrochloric acid at 20 degrees C. So here is this different apparatus. We can see the change in mass was recorded for 60 minutes and displayed as a graph on the computer screen, but the reaction only took 40 minutes to complete, so we want to sketch the graph we would see. So the important things to note is that we would want a point at these two places, at 0 on the x-axis and 117.80 on the y-axis, and then at 40 on the x and 179.63 on the y. And then we would have a nice curve, and we want this end bit to be horizontal because that is when the reaction has finished. Question 2 is about hydrogen peroxide decomposing to give water and oxygen. So first we asked to balance the symbol equation for the reaction. So we would like an 2 in front of the water in order to balance the hydrogens. That leaves 2 oxygens left over, so we add an O2 onto the end. For B, the rate of decomposition of hydrogen peroxide can be measured using this apparatus. And the rate was investigated using 3 different catalysts shown in the table. And the question asks us to state which is the least effective catalyst and give a reason. So we can see from the table the least effective catalyst is catalyst 1. This is because it has the lowest volume of gas collected after any given time, therefore it's the slowest reaction. The next part of the question asks us to plot a graph of the volume of gas collected using catalyst 2 and draw a suitable line. So here is what we will get. We can see a curve. And then the next part asks us on the same grid to sketch the graph we would expect to obtain if we added the same amount of the catalyst to the same volume of hydrogen peroxide of twice concentration. So we should note that we want a steeper curve and it ending at 80 centimeters cubed. Here is a curve that we might get. Again, there is an element of choice as to what your curve may look like here. The next part is about another student claims he could collect more accurate results using the following apparatus. It's just how this apparatus could improve the accuracy of the results. And that is, can replace the bung and delivery tube before reaction starts, so there is no loss of gas. Question 3 asks about the reaction between dilute hydrochloric acid and sodium thiosulfate to make all of these products. So first part, the rate of this reaction can be studied as shown in the diagram below, and using the information from the equation to explain why the cross disappeared. This is because sulfur is formed as a solid, which is insoluble and is precipitated, and the solid then blocks the view of the cross. Part B of this question is about a student who studied the effect of temperature on rate of this reaction, obtaining these results. And another student said that one of the mean values was incorrect. So we were asked to identify which is incorrect and give a reason. Looking at them, we can identify that the one at 45 degrees C is incorrect because of the anomalous middle value, which is nowhere near the other ones, and therefore it shouldn't have been used to calculate the mean. So part 2 then, state what conclusion can be drawn about the effect of temperature on the rate of this reaction, explaining using particle theory. So the higher the temperature, the faster the reaction, the higher the rate. The particles have more energy. So because frequency of collisions increase, more collisions, more have required energy, more achieve activation energy, more are successful. Those kind of wording is what would get you the marks here. So question 4 is about enzymes. Enzymes are biological catalysts. Explain what is meant by the term catalyst. So catalysts speed up the reaction, they lower activation energy, and they are not used up during the reaction. Then the following graphs show the activity of two enzymes A and B as it varies with pH. So we were asked to use the graphs to compare the activity of the two enzymes. Lots of different ways to answer them, so I'll give you all of them. We can compare the active ranges. So A works at a lower pH range, B works at a higher one. You can read the other alternatives here for yourself. Optimum pH, A works best at pH 2, whereas B works best at pH 5.5. Or at given points, both have the same activity at the optimum pH or at pH 3.75. And then the next part asks us about enzyme C, which is found in saliva. It works between pH 5 and pH 9, but is best at neutral pH. So we should sketch the activity and how it varies with pH. So this is what we would expect, a nice curve, again, with the optimum point at 7. Part C is about temperature affecting enzyme activity, which is shown below. So you've used the graph and your knowledge to describe how the activity of a typical enzyme changes as temperature increases. So activity increases to optimum temperature, and then it decreases after optimum temperature, and the rate decreases more rapidly than the rate increases. Question 5 is about the reaction between sodium thiosulfate and hydrochloric acid. This is the same one we saw earlier. During the reaction, the solution becomes cloudy due to formation of a precipitate. State the meaning of precipitate. It is an insoluble solid formed during a reaction. And the next part, the time taken for the cross to disappear was measured as shown below. So then the results from that are shown in the table here. We are asked to plot them, drawing a suitable line. So you should also notice that 0.5 in the table is the last value. That is the first one that should be going on the graph. So we get a downwards trend. The time decreases with increasing concentration, which is exactly the next question. So as concentration increases, time decreases. What conclusion can be drawn about the effect of concentration? As concentration increases, so too does rate. The next question is about a student who used a light sensor to investigate the effect of temperature on the rate of this reaction. Here is the setup and the results. So give one conclusion that can be drawn from these results and how it is shown by the graph. So as temperature increases, reaction rate increases. Or as it increases, reaction time decreases. Then the curve is steeper at higher temperatures, and more horizontal more quickly at higher temperatures. And the next part, slightly less light passed through the tube at the start of the experiment at 20 degrees C than in the others, suggests a possible practical reason for this, and that is a dirty tube or a tube not washed out properly. So then question 6 shows the reaction between magnesium and dilute hydrochloric acid. This is the way it's been measured. So the results obtained at 2 different temperatures are shown below. You see a steeper curve at a higher temperature. Explain the results observed at different temperatures in terms of particle theory. So at higher temperature, faster reaction rate, as particles have more energy. There are more collisions per given time, more frequent collisions, or greater chance of collisions, more collisions with activation energy, or more successful collisions, exactly analogous as to how it was before. Next part, explain the changing rate over time. Rate decreases over time due to reactant particles being used up, so there's less of them. State one way of improving the validity of the results obtained, explaining. So we can ensure the concentration of mass, acid or mass, of magnesium is kept the same, so any change is as a result of temperature changing. The use of a gas syringe, which is more precise and easier to read. The use of a balance to record loss of mass more accurately than volume of gas, or to repeat measurement, calculating mean values which are more accurate. Thank you for watching.